Okay, so this is going to be a rather brief video tutorial on how to create liquid simulations using Bifrost. Um, if you don't have Bifrost here it is, we're in the FX menu set, and you can see it here, Bifrost Fluids. If you don't see this drop-down menu, you can go to Windows, Settings, Preferences, and Plugin Manager, and then you have to find that Bifrost here, and you want to load these. Bifrost is an extension plugin. It was actually created by a different set of software engineers and then acquired by Maya a couple years ago. So you want to make sure that this is all checked here in order to use Bifrost. So Bifrost is pretty simple. You need to have some geometry to emit liquids from. So I'm going to go ahead and put a sphere in the scene. Also remember, we want our playback speed always to be play every frame because we are simulating. So this is at the very least what I need, and I can go to my Bifrost fluids, and I'm just going to show you how to create a liquid. There's no options even here for any of these tools. I just go ahead and say create liquid, and now you see in my outliner it's populated with a bunch of these different nodes that are all Bifrost nodes. And you can see here also, if I zoom in on my, oh, we could see it maybe farther away. You see those little blue dots as we scale in, you kind of we lose them a little bit. So we can see that there has been a liquid that's been applied here, or liquid particles that have been populated within this sphere. So let me go ahead and go to my attribute editor now, and I have a couple different nodes that are attached here to this Bifrost liquid. And we have Bifrost liquid shape, and this gives us many, we have the liquid container and the liquid shape node. Liquid shape node is where many of the properties are that we need to change. The first thing I would say is particle display. This tells you how these particles are displayed in your viewport. It's nice to bump these up so we can actually see them. And if we went ahead and press play, we can see that these particles have been generated and now they're falling under, physical forces of gravity towards, in a negative direction here. The first thing that we can do that's like a single water drop. If I go to my Bifrost emitter props here, so these are the emitter properties, and I can say continuous emission, which is probably what you'll want to check here under emitter properties. So now if I press play, go back to the beginning of my timeline, and now those, now we have more of a flowing stream of liquid. I'm going to jump back up to my liquid 1 here, and that's the emitter properties tab. I'm going to jump back to my liquid shape, liquid container, Bifrost liquid. Let me find this one, this Bifrost liquid container, and then I have here the resolution. So under Bifrost liquid container properties, this is where I have my solver properties, that I have what the magnitude of gravity is and in what direction. And then I also have here under resolution a master voxel size, and this will increase the resolution of the simulated liquid. So just so you can see what this looks like, I'm going to put an Arnold light, just an Arnold sky dome light here in the scene, and let's go to our render view and render this. And there's already been an Arnold shader that's applied by default that makes it look like a kind of clear liquid. So we can see what this kind of looks like here. It's even more apparent how that resolution affects the quality of your render is if I put a collider in the scene. So let's go back to frame 1, and I'm going to maybe I'll choose a cube, and I'll make this cube a little bit bigger. And now what I'm going to do is select my liquid node and my cube node, and then I'll go to Bifrost fluids and I'll say collider. So now this cube is a collider. I can go back and turn back on shaded mode here. So now let's play the simulation. And that liquid is going to kind of splash on top of that surface. So let's stop it here and let's render this. Let me turn on my resolution gate so I can see exactly what I'm rendering. And I'm going to zoom in a little bit. And let's go back to our render view. So you can already start to see that because the voxel size is, it's a pretty big size, that we get some splashes, but this looks kind of more like slime than maybe it looks like water, or it doesn't behave, it doesn't spread the same way that water would. I'll let this complete, or at least get a little bit more, and we'll take a little image of it. Right? This looks kind of wrong. So let's see what it looks like. Take an image of this and let's go back and see what it looks like. What frame are we at? 43. If I, again, go to my liquid properties container and bump this down to like 0.1 and now press play, and you see already that we have a ton more liquid particles that have been populated. So again, voxels are volumetric pixels, and so how many what's the size of those pixels? So if they're much smaller, then when we're rendering this, we're getting much greater detail. So it's not as it's solving. And you see here we have a Bifrost liquid mesh node, and this is what we're rendering out. So these are all of the these are all the nodes that calculate what this liquid mesh looks like, and so it's interpreting between each particle point what that mesh renders out like, what it looks like, and so if there's less particles, we get that kind of jaggedy edges. So let's play through this simulation now, and it will take a little bit longer to simulate. Okay, so let's go to our render view and see what this looks like now with a higher voxel or lower voxel size. And you can already see that we have a much more realistic looking liquid. Now if I don't want to see the sphere that it's emitting from, I can just turn off the visibility in the channel box editor. I could turn that off. I could turn off or on any of those attributes. I mean, any of those objects. So it could just look like, water running from a faucet, or right? So this looks a lot better. Again, the render time for something like this is going to be a bit steep. So you want to make sure that that's calculated into your overall, time that you're allotting for rendering your final animations. So let's see, and we can really see a difference now between these two.